Hello students, this is Mr. Fox, and this lesson is going to be over classifying triangles. So as we saw in our activity, we can classify triangles in different ways. So we're going to just take that knowledge that we had and put it into a chart that we can put into our journals. So if we're going to name this lesson, it'll be Classifying Triangles. Alright, so as we saw, there are two different ways which we can classify triangles. We can classify them by side length, and we can classify them by angle measure. So, starting with side length, we're going to go through the three different types of triangles that we can classify by side length. So the first one will be an equilateral triangle. So equilateral. And equi sounds a little bit like equal, and actually they come from the same Latin root. So that means that they're going to have the same of what? Lateral. Now, when we think about a sport like football, if we're moving laterally, we're moving from side to side. So that's exactly the definition of lateral, is it's a side. So we can say this is equal lateral sides. So it has equal sides. So we can say that our sides are all congruent. And the properties of an equilateral triangle is that all sides are congruent, and all angles are congruent. So our angles are also congruent in here. We also have an isosceles triangle, which you're pretty familiar with. And in an isosceles triangle, we have two congruent sides and two congruent angles, just like our definition of it earlier. So we can say that we have two congruent sides and two congruent angles. All right, finally, we have one more way that we can classify triangles, and I'm sure that you remember this from probably the 8th grade, but this is called a scalene. And in a scalene triangle, no sides are congruent. So I might have something like 3, 5, and 7. So no sides congruent. And I also have no angles congruent. So those are the three ways which we can classify triangles by their side length. We can also classify triangles by angle measure. So our first triangle is going to be one which is an acute triangle. That's where all three of the angles are actually acute. So we'll call this an acute triangle. And so each of these angle measures are going to be less than 90 degrees. So this one might be 80. This one might be 40. And this one might be 60. And the property here is exactly that, is that all angles are less than 90 degrees. Our second type of triangle is going to be an obtuse triangle. And that's where one of the angles is an obtuse angle. And obtuse means that the angle is greater than 90 degrees. So if one angle is greater and finally, we have the ever familiar right triangle. And a right triangle is a triangle which has an angle measure which is exactly 90 degrees. So it has one right angle, the long side is called a hypotenuse, and the other two angles here are complementary. And remember, complementary means that they add to 90 degrees. All right, so that's all the ways that we can classify a triangle by its angle measure. So today we're going to be trying to classify triangles by angles inside and identify corresponding parts. So to be able to identify corresponding parts, we know that corresponding angles or corresponding sides are going to be congruent. So first, let's remember what congruent means. It means that two angles or sides that have the same measure. Okay, great. So let's talk about corresponding angles. So if I give you the triangle ABC and the triangle DEF, well, corresponding angles are those angles that have the same relative position in a geometric figure. All right, so we're going to say that angle A and angle D are congruent, angle B and angle E are congruent, and we'll say that angle F and angle C are congruent. All right, well, if this is the case, then the triangle ABC is congruent to the triangle DEF. We need to make sure that we have those same pieces, the pieces which are congruent, in the same position in the order that we're writing our triangle. So we say that angle A is congruent to angle D. We say that angle B is congruent to angle E. And we say that angle C is congruent to angle F. So that's how we can identify corresponding angles. Now, what about corresponding sides? So if we're looking at corresponding sides, they are going to be sides that share the same relative position in a geometric figure. All right, so let's label our triangles. We have M, P, N, and I'm actually going to write these as capitals instead of lowercase. M, P, N, and the triangle W, X, Y. All right, and I say that the triangle MNP is congruent to the triangle WXY. So knowing that, I can make a couple of statements. So the first statement that I can make is that MN is congruent to WX. So here, MN is congruent to WX. I don't really like this highlighter that I have, so let's change it. I can also say that MP is congruent to WY. And then finally, I can make the statement that NP is congruent to the length XY. All right, so that's how we can determine which sides are going to be corresponding sides and which sides are going to be corresponding angles. If you have any questions, please ask me, and have a wonderful day.